Okay, on sheet 4 of the expansion chamber calculator, we've got basically two sections. This is like um, helping you to design or cut out the pattern for the cones if you're going to be making your own pipe. And this is an essential part of the process of calculating a pipe. So what we have here is the engine compression ratio, the millimeters above the exhaust port from the top of the port to the point of the piston edge at TDC. So this is the exhaust port duration. It's not copying the one from sheet 1 because it's going to allow you to see what's happening in this graph right here, and then you can change it to improve that graph. So right here is the width of the exhaust port every 1 millimeter down the port. And if it's a 2 or 3 port, then you just add them together. So with this and this information and some of the information it's getting from sheet 1, it comes up with this figure right here, which is also, I'm sorry, that's the blowdown area. The figure right here, which is the actual exhaust pressure blowdown time. Blowdown being used in a slightly different way than normal, because people usually use that when they're talking about the time between exhaust port opening and transfer port opening. I'm using it in the sense of the time it takes for the exhaust pressure to blow down to 0. Okay, so what you have, when that piston is going down, you've got this pressure and it's being relieved at the exhaust pipe. Okay, when that pressure gets to less than 5 psi, the transfer can come into the cylinder, because the pressure there is probably about 6 or 7 psi. So here, scroll over. This is graphing the transfer capacity. So when it starts dropping below 1.0 is when it's when the RPM is getting to be too high for it to handle the job. Okay. And this red graph is showing how much intrusion upon the transfer opening the exhaust pressure is. So like right here, if this red line is right at 0.8, that means from transfer opening to 20% of transfer opening, that exhaust pressure still exists. So you've got basically this wasted space and this wasted time before that pressure gets low enough for the transfers to come into the cylinder. So that's part of what figures in to come on up with this graph right here, transfer capacity graph. And so all you need to do is the total transfer width, all the transfer widths added together plus half of the boost port, the millimeters above the transfer port. So on this page it doesn't even use the transfer duration. If you wanted to change to that, you change it by the distance above the port. And then if this right here, this red, right now it says 0.82, that's this right here, the 0.82. So this third number right here is the top RPM according to sheet 1 right here, which may not actually be top RPM. Like on this one, it's actually 8,500. If you wanted, if you went even more accurate, it would be going by sheet 3. This graph right here. When this gets like really down low here, like in this case, 8750 would be like the end of the pipe power band. So if you looked on sheet 4, So 8750 be right here, and that would be still 0.82. 0.82 is good for a single exhaust port, but if you got a double or triple exhaust port, that should be higher. It should be like closer to 0.9. So the fact that this is intruding more upon the transfers than what you want means you should probably raise the exhaust port. Of course, you can lower the transfers, but it's not easy. You're talking about either lathing some metal off of the base of the cylinder or filling the top of the transfer port with JB weld. So, like in this case, it just goes to that end RPM, but like I already showed you from sheet 3, no, we didn't go by sheet 3, but let's say we haven't gotten to that far yet. Just going by this right here, this number right here, 8500. This number right here at 8500, it's right, this transition point right here, it's like 0.85. That's important. So if you want to see exactly what it is, just enter the RPM. And this is showing it at 0.82 still. Okay, but so after you enter all these values, you click the calculate button, which will show you this graph right here. If you're going to change anything, like if we're going to change the transfer port, click calculate again. You see how that dropped down? Because I increased that distance above the transfers, that means I lowered the transfer ports, which means I lowered their top RPM 100% capacity. So if you follow this line out, it's probably whatever that is, 5500. But if you wanted to see exactly what it is, you would have to change this value right here. I'm going to lower that, 1000 RPM, recalculate here. Let's see where that drops off from being 1000. 5000. I thought it was 5500. Okay, it's 5000. Okay. So you can see what happens when you change the value of for the transfers, and the same thing with the exhaust port. You'll see changes here. You'll see changes in both of these when you do the exhaust port. So that's it for that step. Since we're covering sheet 4, I might as well go over this. When you enter the dimensions for the different sections of the pipe, either the diffuser or the baffle. Let's say you got 3 diffuser cones and 1 baffle cone. Okay, so you start with the large diameter, then you put in the small diameter, and then this angle right here from a center line. What that angle is right here. It's not the 2 angles combined with that angle. It says add thickness of sheet metal to inner cone diameter. Yeah, so like when you deal with the diameters on sheet 1 and sheet 2, these are all inner diameters. But right here, you're dealing also with the thickness of the metal you're using. So you need to add that thickness to the diameter. You're not adding twice that thickness because that will throw off the average. So when you do that, each one of these rows out here is a different cone section. You enter those 3, and it'll give you the length of A, the length of B, A and B combined, the chord, and the angle. Okay, so the angle is this A right here. The chord is this straight line right here. So, so when you start off, you just length A. That's A. Yeah, start off using length A and B. You would draw a line on your poster paper, marked at both ends, and then you would move that ruler, let's say over here, and you would mark these two positions here, and you move it again, mark those two, and so you're going to have a dotted line for these two right here. And you make it probably longer than you think, well, just going by the chord, just eyeballing it with the chord, you make it a little bit longer. And then use drawing by hand those dotted lines, and then you measure the chord length and see where along that curve right here that chord distance falls, and then you mark it there, and then you'll draw a line right back to the pivot point right here. And then what you would cut off is this section right here. This is going to be the pattern for that section of the cone. So you can put that on top of sheet metal, use a felt tip marker to mark around it, and then with your tin snips, move the paper and then cut that section out of the sheet metal. And then you can curve it by hand with the help of pliers and a rubber mallet, putting it on top of a curved something or other, like a pipe or like a bicycle front fork tube. So yeah, that's it. That's sheet 4. Thanks for watching.